In this video we will have a look at the function, its derivative and the second derivative. Now what you see here is a function, and you may recognize it as a cubic function. This shape is for a cubic function. And there's a point A on the function that I can move about. Now if I want the instantaneous rate of change in this point A, I need to find the slope of the tangent. So here's the tangent. The function goes very steep here, tangent of 19.4, the slope. And when I go up here, the tangent is horizontal, the slope is 0, which means a maximum on the function. And I go down, slope gets higher again, up to negative 6.3, but then it decreases again, back to 0, and here positive because the function is increasing. Increasing, positive slope, decreasing, negative slope here, and here increasing, positive slope. Now since this is a cubic function, so x to the power 3, for instance, if when I derive x to the power 3, you may know it's 3x squared. So when we find the derivative of a cubic polynomial, the outcome is a quadratic polynomial. And here it is. So this is the derivative of our cubic, and it's a quadratic. Let's have a look at some interesting points. Here, where the tangent to the original function is 0, the slope of the tangent, there of course the value for the quadratic is 0. The value of the derivative is 0 because it is the slope of the tangent, 0. Here as well, when the slope of the tangent is 0, the derivative is 0. Right there. Another interesting point is here where the slope is most negative, negative 6.3, because that coincides with the vertex of the quadratic, the minimum of the quadratic. So what happens there? Well, just as where the maximum of the function denotes a 0 for the derivative, and the minimum of the function is a 0 for the derivative, when we find a minimum for the derivative, that needs to be a 0 for the second derivative. And there it is. The first derivative is quadratic, therefore the second derivative is a linear function, and it is 0 when the derivative has a minimum. And that coincides with the highest negative slope on the original function. And that is exactly what we call the point of inflection right there. It's where the original function goes from concave to convex. Right? So a cave shape like that to the opposite. And it's a point of inflection. So I'll draw it out for you. If you have a shape like this, it suddenly curves the other way. First it curves this way, and now it curves that way. There in the middle is the point of inflection. So the function is a cubic, the derivative is quadratic, and the second derivative is a linear function. Where the second derivative is 0, we have a minimum for the first derivative. And a minimum for the first derivative indicates the steepest slope for the original function, right there.